So in our first semester class, we stuck mostly to using primitive data types. We did use string, which is a reference data type. So I just want to talk, before we create our own classes, I want to talk about some of the classes that Oracle has that are called wrapper classes. And that's because they wrap the primitive data type into an object so that you have more usability. So you might remember int as a primitive data type. We used int a lot in semester 1. But we also use the integer class. And where we use that specifically was we used it in a static method called parseInt. And we didn't talk much about it, but I'm going to talk a little bit about it in this video just to illustrate the difference between a primitive data type like int and a reference data type like integer. So I'm going to create two variables. I'm going to create an int called number 1, and I'll set that equal to 3. And then I'm going to create an integer called number 2, and I'm going to set that equal to a new integer number 3. So far, they look about the same. If I did a system out print, and I could say number 1, put in some spacing, and print out number 2. I can run this thing, and I see both of them come out just fine. The difference, however, is that when I'm looking at number 1, that's all I can do with it. It's a one-trick pony. I can use that as an int. I can perform mathematical operations on it. So for example, if I wanted to have another int called another number, oops, and set that equal to number 1 times 5, no problem, I can do that. If I tried to set another number equal to number 2 times 5, again, no problem with that. Those will both work just fine. But that's about it for int. Int can store a value, and you can do operations on it on an int, but that's about it. If I go over to the Oracle class and I look at the integer, the actual integer class, I mean the Oracle site, and I look at the integer class, I see that there, well, first of all, there are a couple ways to construct an integer. So that's interesting. So for example, I can construct it like I just constructed the number 3 by giving it an int value as the original amount. Or, and this is what we did in semester 1, I'm going to create a new integer called number 3. I'm going to set that equal to a new integer. And this I'm giving a string value of 3. And my computer says, cool, no problem. I know what that means. And I can still perform mathematical operations on it without any errors at all. So that's fine. It works. I run that. I never printed out another number, but there's no errors. Everything works fine. If I wanted to print it out, I can print that out. No problem. So that's kind of cool. It came in kind of handy when we were reading in using a JOption pane, for example. Even more handy. So this tells me also that we could have done that differently. I'll let you think about how we could have done that. We used a different method when we read in a string. So speaking of methods, look at all the methods that you can perform with an integer object. So the one that we used a lot in semester 1 was this parseInt, but you see there are an awful lot of them. So just to let you know, that's one very big benefit to using a wrapper class is that I have now access to a whole bunch of methods that I can use. Now, for a lot of these, you might be like, well, why would you want to? Because equals, we can just use double equals sign with int, and that's fine. And that's true. Some of these might be more useful than others. But somebody needed them somewhere along the line, so they created them. Byte values. So you might play around with some of these. One way to learn how to program is just to try things. So this returns a byte. It's called byte value. It returns the value of the integer as a byte. So that's kind of interesting. So if I wanted to, I could say something like system out print line, and I could say, which one was an integer? Number 2 as a byte is, and then I could just say, what was the name of that thing? It was called byte value with a capital V. So then I could use number 2 as the object to get me over to that class, dot byte value with a capital V. And now when I run it, I can see, yeah, it has a byte value of 3. Well, that wasn't as interesting as I thought it would be. So you can just go on and decode the string. Oh, that's not very interesting. To a binary string might be interesting. Returns a string representation of the integer argument as an unsigned integer in base 2. Ooh, let's do that. It's called to-binary string. So that might be more to-binary string. What would that look like? To-binary string. And then we have to send it some integer value. 1, 1. Ooh, and that is the number 3. Now, the interesting thing about this is, do you notice how it says static over here on the left side? That word static means that I don't have to use number 2 to call on that binary string. I can use the class name itself, and then I can send the integer value in here. So that's what static means. It means that I can call on it anywhere. I can call on it with just using the name of the class as the object. So there's a whole bunch of information for you. Hopefully this helps you understand wrapper classes and the difference between static and non-static return values. So good luck, play around with that. You'll learn more by playing with it yourselves.